Hello everyone, good morning and welcome again to our online science class. How was your week? Did you have a great weekend? Well, me, I have a really great weekend. So for now, it's Sunday, April 19th, and we have another exciting topic for science, and we're going to guess later what is it. But for the meantime, I want you to get your course book, and we need an extra paper here for note taking as well as for solving. We're gonna have solving today, and if you don't have them, kindly hit the pause button and get them. We really need it right now. If you're ready, I'm gonna give you some mind-boggling questions here that you need to answer. Okay, I'm gonna test how keen is your hearing and how familiar are you with these sounds. Are you ready? If you're ready, let's go. This is question number 1. Listen carefully. Time is up. Do you guess the animal with this sound? If you answered eagle, that is right. That's the sound of an eagle. This is question number 2. Name the animal with this sound. What could that be? Do you have any guess? Let's see. It's zebra. The answer is zebra. Next question. Guess the animal with this sound. Let's see if you guess it correctly. The correct answer is, of course, it's dolphin. Did you get all 3 marks? If you get all 3 marks, that means your hearing is really good and you're really familiar with a variety of sounds. So please let me know how much you get on the comment section below. So what do you think is our topic for today? So let's see. Our topic for today is all about looking at vibration. It's still all about sounds. It's a continuation of our topic last week. So if you have your course book, kindly open it on pages 138 and 139. And we're going to learn this stuff for this session. We're going to differentiate amplitude and frequency of a vibration. We're going to define also what's the amplitude and what's the frequency and what does it do with the sound. And we're going to have some calculations here referring to the frequency of the sound. So that's gonna happen after we define and differentiate what is the frequency and what's the amplitude of a sound. So before that, just want to ask you and refresh your mind about this question. Seen there is a guitar, and why do you think the guitar found there produces sound? There's one reason why all of the things in the world produce sound, and what is that? Okay, you said vibration. That is correct, and I want you to recall what is vibration again. So what's vibration? So we're gonna take a look here with different vibration, and of course with vibration it creates sound. So I want you to arrange the letters here. It's A, B, C, D, and E, and I can see I have here the picture, only that I don't have the sound because I put them simultaneously. It's gonna be so chaotic. So I want you to arrange the letters here from the sound with the least pitch to the ones with the highest pitch. You have there A, look at A, B, C, D, and E, and you may have to use your imagination. Please write your answer in the comment section below or send me a message about it. Or I want you to take it note and take a picture and send it to me. I'm gonna give you a minute to make up your mind to arrange the letters down right over. So, do you already have the answer in mind? Can you see it? Did you type it in the comment section? That is great. Let's check your answer with mine. So I have here the arrangement. So the D has the least pitch, and the A, of course, it's a siren of a police, and it's really painful to the ear sometimes when you hear it. So it's the one with the highest pitch, and we have here the bass drum, we have here the crying, a baby, and a screaming lady, and well, letter A has the highest pitch. So why did we arrange this sound according to this? From D, B, E, C, A. What might be your reason? Can I hear it? So I have here my own reason. So this is caused by the number of times the object or the source of the sound vibrates. So that means the vibration found in letter D tends to have different with the vibration found in letter A. It might be this one, might be the slower, and this one might be the fastest among all of these 5, and that creates A to have the highest pitch, and thus D has the lowest pitch. So let's take a look here. Why does this happen? So I have here rulers. So you can have the transparent one or the metal one, and if you don't have them, kindly hit the pause button. We're gonna do the same thing with what I did here in the video, and it's really a best way to explain what is an amplitude. So the question here is, what will happen to the sound when we adjust the length of the ruler, just like what's being done there. So a part of the ruler is you place it at the top of the table, and the part of that left hanging, it's away from the table. If you attended the Zoom live class, we did it with the actual ruler, and your classmates had listened to it. So I'm gonna just put this at the side, and we're gonna watch the ones here in the video that I provided. So let's try to see what will happen. This one has this length, and try to listen with the sound. Okay, I'm gonna repeat it one more time. I want you to put your volume up and listen carefully to the sound, and try to see the length of the ruler, which is placed here in the table, and the ones which were hanging right over here. And all we need to do is to stroke the ruler, just like what the previous few seconds a while ago had presented to you. Alright, so are you ready? Let's go. Try to listen to the quality of the sound. And also, I want you to notice the vibration here. Since we're talking about sound, we're talking here about vibration. So for the ruler to make a sound, it needs to create a vibration. That is great. So I want you to take a look also and describe how does the ruler here vibrates every time it's being struck, depending on the length of the ruler, which is hanged over here away from the table. So let's repeat it one more time. This one is the shorter, and we increase the length, and we keep increasing the length and try to listen to the sound. Alright, so question here is, what happens to the sound when we adjust the length of the ruler? Did we increase something? Well, granting that we use the same force, that the loudness tends to be the same, what happens to the pitch? Please let me know in the comment section below, or send me a message about that, and I'm really interested with what's going on in your mind. Alright, so we call that the amplitude of the sound. So every time we do this, we do the experiment, we are creating a sound, and what's happening here is sound creates vibration, thus there is a sound wave. So I want you to take a look with this one. So whenever we say amplitude, look at this. What are we adjusting if we adjust the amplitude? This is the entire sound wave. So we call this one as your wavelength. Just never mind the phase first. We're gonna take a look with the phase on our next topic, but I just want you to focus yourself on the amplitude. Look at this one. So if we are adjusting the amplitude here, we are adjusting here actually the height or the distance of the vibrating object as it moves from its rest to its rest before it started vibrating. So the one here, it's time, so you vibrate it at the course of time. The one here is the resting phase or the resting position of the ruler. So when I vibrate it, it reaches this distance and this distance. So look at this one. We call this one now as your amplitude. So that the distance from here until here is what we call the amplitude. So the amplitude here, the height of the amplitude here, created when we vibrate an object depends upon will depend on the pitch that will be produced. So the question here is, if I increase the amplitude, the height of the amplitude or the distance of the amplitude, am I increasing the pitch? Am I making a high pitch? If I decrease it, am I making a low pitch? So let's take a look of that, and we're going to answer it in the course of time. But I just want you to take note here that what is an amplitude? So just an amplitude is just the distance here of the vibrating object. So this is a wavelength. So the distance which is created here in the wave is what we call the amplitude. So the amplitude can be increased and the amplitude can be decreased, and I want you to take note later what will happen to the quality of the sound. We're talking here about the pitch of the sound. That's the pitch goes up or the pitch becomes lower. Alright, so let's take a look with another experiment that was did here. So we're gonna test the hypothesis at if the length of the ruler is related to the pitch that is produced. So I have here a 4 inches ruler, a 6 inches, and an 11 inches ruler. We're talking here about the length of the ruler that is hanging away from the table. So this is my question here. Which of the 3 rulers here will be producing the highest pitch? So at this moment, I want you to put your sound louder and try to listen carefully to the sound. So we have here the 4-inch, the 6-inch, and the 11-inch ruler. If you can't hear it properly, I wish that you can do it at your house, or if you're watching it right now, only get a ruler and try to do the same thing. Alright? So let's listen now. Alright, so which of the 3 rulers here produces the highest pitch? Definitely that is the 4 inches ruler. So the question is why it's the 4 inches ruler. Let's take a look with the concept right over here. So how is the length of the ruler related with the kind of sound it produces? So I have here another experiment that I just want to present it to you. We did it already in the Zoom live class, so I just want you to take a note with this. So vibration is said to produce sound. So what we did here is we need a cardboard, a pen, and a box like this. So you can, if you want to, you can improvise it at your house. So we're just going to wrap or put the rubber band around the box over here. We're gonna be needing this pen, and we're gonna put this here. This one will represent the length. So this one tends to have a longer length, and we're gonna adjust this one to show you a shorter length. Alright? So let's take a look. So I want you to put your phone or your laptop at full volume right now. Let's try to listen to the quality of the sound which is produced. I'm gonna repeat it one more time.
Plug the band now. The rubber band starts vibrating.
sound. Try to take note of the sound which is produced in here. So what do you think? Is it lower in pitch, or is it higher in pitch?
We will not hear any sound as soon as the rubber band stops vibrating. So it is clear that sound is produced by a vibrating body.
So if you notice there, if the length of the rubber band is longer, it tends to produce a lower pitch than the shorter one. So the same thing with the ruler that I have shown to you a while ago. So why it's a 4 inches ruler? Because the shorter its length, its distance is, the higher is the pitch. This shows that if the wavelength tends to be closer with each other, what will happen is the pitch of the object or the sound will become really high. Okay, so just take a look with the ruler right over here. So what is this talks about the frequency now. So what is a frequency? The frequency will tell you about the number of vibrations which are found every second that a certain kind of object will vibrate. So here, let's try to see which vibrates here more per second than the other. So definitely, if you can see here, is a 4-inch ruler vibrates more. This shows that if we shorten the wavelength here, okay, or the distance from one cycle, if the distance from one cycle to another cycle is shorter, okay, this shows that the vibration is more compared to the other kinds of vibrations. A longer length here, this shows that it has a higher frequency. So an object that produces a complete vibration is the one, or is the object that moves up from its rest position, then back down towards its rest position one more time. So it's what we call complete vibration. So I would just like you to focus yourself on the sound waves that I have here. So this one is an amplitude. So one wavelength is equivalent to an amplitude, which 2 amplitudes actually. So that's one amplitude from this rest position until it vibrates down. So it vibrates up, that's one amplitude, and it vibrates down, that's one amplitude. So these 2 amplitudes that's produced here is what we call the complete vibration. So this one cycle here is is equivalent to 2 wavelengths. So these 2 wavelengths creates now complete vibration. So to wrap it up, what is frequency? So the frequency again is made up of how short or how long are the one wavelength is from the other. So again, if one wavelength is shorter, the distance between these 2 is shorter, that means this is compressed. So if you imagine this one is compressed, and I've shown how does the sound waves looks like in a previous video. So what will happen is the pitch will become higher. So in this case, I want you to focus again yourself here in sound wave. Is this a higher pitch or a lower pitch? Definitely, this one is just a lower pitch. However, if we decrease the distance here between the wavelengths, what will happen is we increase the pitch. Alright? So we're talking here about frequency, and that will talk us about the number of times that a certain object tends to vibrate over a period of time, and thus we can solve for the frequency of a certain sound. So I have here a situation. A ruler vibrates or oscillates, is another way of saying a vibration, for 20 times in 25 seconds, let's say. So what is the frequency of the ruler? So we're going to take here also what is the unit for the frequency. So first is we're going to write the given. So the given here would be the time and the number of vibrations. So the time here is 25 seconds, and the number of times it vibrates is 20 seconds. So all we're gonna do is to identify the formula, and of course the formula for getting the frequency is just divide the vibration by the time. So we have there So we're gonna replace these variables with the numerical value found on the problem. So the vibration that we have there is 20 times, and the time there is 25 seconds to create this one. So it is said that one hertz is equal to 1 vibration per second, and it's the symbol of Hz. It's discovered by scientists Hertz. So we're gonna use here the symbol Hertz to express the frequency of the sound, and I want you to remember that 1 Hertz is equal to 1 vibration for every second. So all we need to do is to divide the vibration. For the time here, it's 25 seconds, so 20 divided by 25, and that will give us the value of 0.80 Hertz. This means that if you have 0.80 Hertz, well, the number is less than 1 here. This shows that it has a shorter frequency. So let's compare this with the other values or the other answers that we're gonna get in here. Alright, so let's practice solving this one. So if a bird here flaps its wings up and down 50 times, and this is now our vibration, in just a period of 20 seconds, what is the frequency of the flapping? So first is, we're gonna write there the given. So what are given there is the time and the vibration. So the time there is, the vibration first is the 50 times, and the time there is 20 seconds. So we're gonna write there the formula. So the formula to get that is simply frequency is equal to vibration over time, and we are going to replace the variable here with the numerical value. So vibration is equal again to 50 times. So we're gonna write here 50 times, and the time here is 20 seconds. So all we need to do is divide 50 by 20, and that will give us a value of, exactly, that will give us a value of 2.5 Hertz. So again, I want to go ahead that we're going to compare this answer right over here with the previous one. So which do you think has a higher pitch? The ruler over here or the flapping of the wings of a bird? Great. So this, is it the ruler or the bird? Exactly, it is the flapping of the bird's wings. So take note that the higher the frequency is, the higher is the pitch. This means that it only has a pitch of a frequency of 0.80 Hertz. This shows that it can only vibrate over a longer period of time compared to the ratio of this one. So this one, last time, it can vibrate for a period of time. So the higher the value of the frequency is, the higher is the pitch. Alright, so let's take a look with another problem here. So here, a string has a frequency of 60 Hertz at a period of 50 seconds. How many times did it vibrate? So in this case, given here are the time and the frequency. So we're gonna solve here for the number of vibrations. So given here is a time, and that's the 50 seconds, and the frequency, which is 60 Hertz. It's a really high pitch. So we want to know here how many times you think that the string had vibrated over a period of 50 seconds, which produces now 60 Hertz of frequency. So we're gonna write here the formula. So the formula to get that is, I want you to take note of this, hit the pause button and take note of that on your notes. It's V stands for vibration is equal to frequency times time. We're gonna substitute the value here. So frequency is 60 Hertz and time is 50 seconds. So all we need to do is to multiply 60 by 50 seconds, and that will give us a vibration of 3000. So this means that to produce a 60 Hertz of frequency over a period of 50 seconds, the string has vibrated 3000 times. It's a really high frequency, right? So, and it's really fast. It's 3000 vibration over a period of 50 seconds. That's near a minute. So, take note of the formula right over here. Alright? So, let's take a look with another problem here. So So the drum skin has a frequency. By the way, a drum skin is like where you tap the drum. So it has a frequency of 75 hertz, which vibrates now for 500 vibration. So we need to calculate here the time when the drum skin produces this frequency. So what we're asking here this time is the time. So we're gonna write here the given. Given are the vibration and the frequency. So the vibration is 500 vibrations. So 500 vibrations here, and the frequency is 75 hertz. So we need to solve here for the time it takes for the 500 vibrations to produce 75 hertz sound. So we're gonna write here the formula. Again, I really want you to take note of the formula to get the time here given the vibration and frequency. So time is equal to vibration over frequency. Please write it in the notes that you have right now. So we're going to substitute the variables here with the numerical value. So vibration is 500 vibration, or 500 times. Well, sometimes the vibration here becomes time, sometimes it becomes a vibration. So please don't get confused between time and number of times. Alright, so frequency here is 75 hertz. So you simply divide 500 divided by 75, and that will give us 6.7 seconds. So take note that we really need to put a time in here. So I want you to observe, if time is a value, it's usually in seconds. If vibrations, we just put their vibrations. And if it is frequency, the value here is vibrations per second or over a period of time, and that will give us Hz, which stands again for hertz. That is the standard measure for the frequency. Alright, so I want you to review the video again if you need more time for that. However, if you are ready, I just want you to take note again one more time of the formula over here. So that is the formula for getting the frequency. Look at it very carefully for the time and for the vibration. So if you're ready, let's test how much you know about frequency. Alright, so let's have some sort of quiz. Ready? Let's go. This is question number 1. The string of a guitar vibrates 70 times in 3 seconds. Calculate the frequency of the string. I'm gonna give you a minute to solve for this. Time is up. Let's see if you get it correctly. The answer is 23.3 hertz. Given here is the time, just 3 seconds in vibration at 70 times. So formula is vibration divided by time. 70 times divided by 3 seconds, and that will give us a value of 23.3 hertz. So 1 mark for the given, 1 mark for the formula, 1 mark for this working here, and 1 mark for the correct answer with unit. You get it correctly? That's 4 marks. Great job. Next question, this is item number 2. The vocal cords has a frequency of 55 hertz. To produce this sound, it needs to vibrate for 90 times. So how long does it take to produce this sound? Again, what is the given? I'm gonna give you 1 minute to answer. Your time starts now. Let's try to see if you get it correctly. The correct answer is it's 1.60 per second. So given there is the frequency, which is 55 hertz, vibration at 90 times. So the formula is frequency is equal to, it's time. Time is equal to vibration over frequency. So T is equal to 90 vibration divided by 55 hertz, and that will give us a time of 1.64 seconds. Did you get it correctly? 4 marks for that. Let's take a look with question number 3. The wings of the bee has a frequency of 30 hertz for 0.5 seconds. How many times did it vibrate? So what are we asking here? I'm gonna give you a minute to solve for it. Your time starts. Let's check if you get it correctly. The correct answer is it's 15 vibrations. So frequency is 30 hertz. Vibrating over a time 0.5 seconds. So vibration is equal to F, that's frequency, multiplied by time, and that will give us the value of 30 hertz multiplied by 0.5 seconds. Vibration is equal to 15 vibrations. Did you get it correctly? That's 4 marks, so please add all your marks from question number 1, 2, and 3, and let me know on the comment section below. I really want to know how much marks did you get. So if you missed some of the marks on 3 questions, kindly hit the pause button and review the slides one more time. Just rewind, just take your time on your own pace. Alright? So if you have any question or clarification about this video or about this lesson, kindly send me a message or write it again in the comment section below and just let me know. I'm really interested if you have a question or what's going on in your mind. Alright? So that will be all. Your worksheet will be given this coming Wednesday. If you don't have any question, well, see you on our next meeting. And that will be on Tuesday. Good luck, stay safe, and goodbye.